students, in this presentation we are going to see about lock-based protocols. Lock is a mechanism used to control concurrent access to a data item. When a transaction wants to access a data item, it should first lock the data item, then perform the operation either read or write on the data item, then it releases the lock on the data item. This is the locking mechanism. There are two types of locks, shared mode lock and the exclusive mode lock. When a data item is locked in shared mode by any transaction, then the transaction can perform the read operation on the data item. And when a data item is locked in exclusive mode by any transaction, then the transaction can perform both the read operation as well as write operation on the data item. So this is the lock compatibility matrix. S stands for shared lock and X stands for exclusive lock. So the meaning of this matrix is S is true. That means when a transaction is granted a shared lock on a data item, and if any other transaction requested for shared lock on the same data item, then it can be granted. That's why S is true. Now S X false. That means when a transaction is granted a shared lock on a data item, and if any other transaction requested for or exclusive lock on the same data item, then it cannot be granted. That's why S X false. And X is false. That means when a transaction is granted an exclusive lock on the data item, and if any other transaction requested for shared lock, then it cannot be granted. And if it is also not only shared lock, when a transaction is granted as exclusive lock on item, and if another transaction requested for either shared lock or exclusive lock, it cannot be granted. From this we can conclude that any number of transactions can perform read operation on the same data item at the same time by holding the shared lock. But if any transaction is making write operation on the data item by holding exclusive lock, then no other transaction is granted either shared lock or exclusive lock. Now here is an example of a transaction performing locking. So here the transaction T2 performs the following operations. It is reading the data item A, then reading the data item B, then performing A plus B and displaying the result. So here to read the data item A, first it locks the data item A in shared mode, then read A, then it releases the lock. And then to read B, it locks the data item B in shared mode, then it reads the data item B and then releases the lock. And then it is performing the sum operation A plus B and displaying the result. This is the operations involved in the transaction T2. Now, what is the locking protocol? Locking protocol is a set of rules followed by all the transactions while requesting and releasing locks. Now look at this schedule. Here two transactions are participating in this schedule, T3 and T4. Now T3, the schedule is in such a way, first the T3 perform the following operations. It is locking the data item B in exclusive mode. It is reading B, performing the operation B minus 50, then writing on the data item B. Now the T4 enters in the schedule. The T4 first locks the data item A in shared mode. It is reading A. Now it is locking the data item B in shared mode. But now this lock request cannot be granted because the data item B is already locked by the transaction T3. So now the T4 is not granted the shared mode lock for the data item B. So it waits infinitely. Infinitely it is waiting. So this situation is called the deadlock. So to avoid this deadlock, one of T3 or T4 must be rolled back so that lock can be released. So another drawback of lock-based protocols is starvation. So starvation is what is starvation? So if a transaction requests for a lock on a data item and it is never granted, and the lock, it is waiting for a long time for the that is mainly for an exclusive lock on a data item. This situation is called the starvation. Okay, so the transaction is repeatedly rolled back due to deadlocks. So this starvation occurs since the concurrency control manager is badly designed. So concurrency control manager should be designed properly to prevent starvation so that all the transactions are granted the locks at some time. So in this two-phase locking protocol, each transaction issue lock and unlock request in two phases. There are two phases, growing phase and shrinking phase. In the growing phase, a transaction may obtain locks but may not release any lock. In the shrinking phase, a transaction may release locks but may not obtain any new locks. So initially, a transaction is in the growing phase. The transaction acquires locks as needed. Once the transaction releases a lock, it enters a shrinking phase and no more lock request can be issued. So this two-phase locking protocol ensures conflict serializability. The disadvantage of this two-phase locking protocol is it leads to deadlock state. So to overcome this deadlock state, we use another modified protocol called strict two-phase locking protocol. Here, the transaction must hold all its exclusive lock till it commits or aborts. So when does a transaction commits? Once the transaction completes all its operations, then only it commits or aborts. So a transaction must hold all its exclusive lock. It should not release any exclusive lock till it commits or aborts. That is strict two-phase locking. And another is rigorous. Another type is rigorous two-phase locking protocol. This is even stricter. Here all the locks, not only the exclusive, here all the locks, the shared locks and the exclusive locks should be held till commits or abort. The transaction should not release either shared lock or the exclusive lock until it make the commit or abort operation. So what is lock conversions? Converting from one lock mode to another lock mode. So can convert a lock mode, shared lock mode to exclusive lock mode. This is called upgrade. And conversion of exclusive lock mode to shared lock mode is downgrade. Lock manager is a process. Each transaction sends lock and unlock request to this lock manager. The lock manager replies to the transaction by sending the grant messages. And also this lock manager maintains a data structure called lock table in which it records the granted locks and pending requests. In the graph-based protocols, an order is maintained in which the data items can be given access permissions. So here the data item is ordered in a set D equal to D1, D2 up to DH. That means if a transaction is accessing any of the items, say D2 and D5, then first D2 only should be given access permission, and then only D5 can be given access permission. So in this way we can give the lock grant access. So this is a tree protocol. Here also we have an order in which a transaction can access a data item. It is initially a transaction can lock any data item, and while locking for the second time, that is a data item Q can be locked by TA only if the parent of Q is currently locked by TA. If the parent is not locked, then the data item already held may be unlocked at any time. In this presentation, we have seen about one of the concurrency control mechanisms, lock-based protocols. Thank you.